Moving forward with 4.5, we'll be finding values of trig ratios. And we'll be referencing talking back to the reference angle. We're practicing drawing, positive coterminal, negative coterminal, etc., etc. The main thing to do, though, is if we start in degrees, we usually want to end in degrees. And if we start in radians, we want to end in radians. So, as a reminder, negative angles means we're going clockwise. That would be negative 360. If you add another 90 to that, I guess I'm still subtracting 90 though, it would be 450. So a little bit more than that. And if you need to, use a calculator like 90, 180, 270, 360, 450, and so on and so forth. Okay, so I guess that would be helpful to write out negative 450 and think about that. You would have to have another negative 23 degrees to get back to that value. So as far as a reference angle, we'll use theta. Just a reminder that we want the smallest acute angle, positive acute angle, that's made with the x-axis. So if you think about it that way, it might be helpful to think, oh, well, if I only have 90 degrees here and 23 of it's taken up, maybe just do 90 minus 23, to get 67, if my math is correct. And we'll call it theta prime for the reference angle is 67 degrees. What else do we need? A positive coterminal and a negative coterminal. I think what I would do is just leave that negative 473 and start adding 360 to it. So one coterminal would be negative 113. If I add, so build a box around that, and then add another 360 to that. Adding another 360 to that will give me a positive 247 degrees. And that should be confirmed if you think about, well, where does 247 degrees? It has to end in the same position, same ending. And that is in the third quadrant, so that should make sense. As we move forward to the next one, again, starting in radians, we should end in radians. Whoa, that was bad. I'm just thinking about, okay, well, if we were talking about pi radians, that would be 7 pi over 7. We're going counterclockwise. So 13 is definitely bigger than that. Well, if I were to consider 2 pi, that would be equal to 14 pi over 7. Okay, so it's definitely not quite that far. And your angle doesn't have to be perfect. Mine definitely isn't. But that helps me understand that we are going to be in the fourth quadrant, and that reference angle right there I just need one more pi over 7 to get there. So there's my reference angle. What else do we need? Just using the same logic of coterminal. I'll start with 13 pi over 7. And instead of adding 360, I can add 2 pi, but notice that I'm just rewriting 2 pi as 14 pi over 7. So as I add that together, that gives me 27 pi over 7. Remember, the denominator stays the same. And then I can do the same thing, but subtract to get negative 1 pi over 7. So there's 2 more answers for you. One positive, one negative. So for each of the angles, determine what quadrant. I think we've done this before, just kind of adding to this. So if cosine's negative, I think it's your reasoning is fine if you go ahead and just circle. Okay, well, cosine's negative in the second and third quadrant. Cosine's positive in the first and fourth. Tangent is negative in the second and fourth. Tangent's positive in the first and third, leaving us with quadrant 2, Q2. It'd be nice if you wrote out some words, but I think this is good enough reasoning. I really, really want you to stay away from saying quadrant 2 because cosine is negative and tangent is negative. Yeah, that's right, but anybody that knows less than 0 is negative could write that out too. So I'd rather see some visual like this that you're showing me that you understand. Okay, looking at the next one. Now this one you could definitely write out that cotangent of theta is cosine over sine. Remember, cotangent is the reciprocal sine, so since sine is cotangent is the reciprocal of tangent, and since tangent is sine over cosine, then cotangent must be cosine over sine. There we go. Hopefully I said it correctly that last time. Is undefined implies that sine is equal to 0. Well, let's look at where does sine equal 0. Let's use a highlighter. Let's go with this color highlighter. Sine is 0 on the positive x-axis and negative x-axis. If you need a reminder, it's because this ordered pair is 1, 0. Sine is the y-coordinate. Negative 1, 0. All right, let's look at the next piece. Okay, so cosine is negative. Where's cosine negative? Well, we kind of had that earlier. It's over here, not over here or here. Cosine's positive over there. So that, I think, is perfect work to show that we are going to be on the negative side of the x-axis. And I would much rather see this work than a long, drawn-out paragraph. I'll read your paragraph if you write it. I'd rather see something like this with a quick picture. I think that's more meaningful than, I don't know. So I'm just going to move on. Okay, so what we're going to do is we're going to get away from the unit circle for a second, and we're going to examine different angles with different points. So the reason why I'm saying we're getting away from the unit circle is if I were to draw this out and have the ordered pair of 5, negative 3, there's no way that this radius is 1. But that's okay because alpha so I guess I should write this out. Alpha, and I write it like this Greek. I write it this way. But anyway, typically we write it as this. But as far as we're concerned, alpha is just some ratio, and it doesn't matter if you do a positive or a negative angle or if you did several rotations. But we're looking at this point, and the x-coordinate would be 5, the y-coordinate would be negative 3, and if we did the Pythagorean theorem, we could figure out that hypotenuse, hypotenuse would be 5 squared plus 3 squared. You don't have to worry about it being negative because when you square something it becomes positive anyway, equals, I'll just use C for the typical Pythagorean theorem, squared. So 25 plus 9 is 34. So that means that the square root of 34 is that hypotenuse. And the whole reason why we need that is now we can identify that sine of alpha is equal to the opposite of that angle, or angle made with the x-axis. It doesn't matter if you go clockwise, counterclockwise, over the hypotenuse. And it'd be nice if you rationalize. You don't have to. But I'm going to. Negative 3 root 34 over 34. Which actually makes cosecant pretty simple. And I would actually look at the original, not the rationalized one. Just rewrite as negative root 34 over 3. Yeah, let's change colors. Just to liven this up a little bit. So cosine would be adjacent, 5 over root 34. And then when you rationalize that, 5 root 34 over 34, and, which will lead me to secant. And again, just rationalize the unrationalized one, and reciprocal that, flip it, and you should be good. And then just to give your last ones, tangent and cotangent are pretty straightforward. because tangent's opposite over adjacent, so just -3/5, nothing to rationalize, and then cotangent is the reciprocal of that, so -5/3. There we go, and we have it. And if we're in the fourth quadrant, it makes sense that cosine and secant were positive, and everything else was negative. So as we look at the next one, -3, -2. Alpha again, but actually doesn't really matter. So do the Pythagorean theorem, 3 squared plus 2 squared. So 9 plus 4 is 13. The square root of 13 would be that. I mean, I trust that you can use a calculator or do that in your head. So sine of alpha would be -2 over √13. Again, some teachers accept that. Other teachers will want you to rationalize. Please let me know if you do not know how to rationalize. I'm just going in order. Cosecant, just flip that, -√13 over 2. So cosine adjacent, so that would be -3 over √13, or rationalize that. And that means secant would be the reciprocal. Tangent, notice it's a negative over negative, so it's going to be positive. Opposite is 2, adjacent is 3, and then cotangent will be the reciprocal of that, 3 over 2. I think that's all we needed to do with that one. And we're going to get into a little bit trickier of things. Now, this is on the unit circle, or you can make it on the unit circle, but you don't have to. Okay, so in this problem, first of all, we have 2 clues to figure out what quadrant we're in. What quadrant are we in? Well, sine is negative. So if we're just examining that, sine is negative over here, but we also have this clue that says tangent is negative. Well, tangent's negative in this quadrant. It's also negative over here, but sine is positive up there. And everything's wrong about the first quadrant, so we have 2 negatives. So let me draw that picture. If sine is opposite over hypotenuse, and right here is alpha, we'll make this -3, and the hypotenuse would be 5. If you do the Pythagorean theorem, you'll get 4 over here. I'm not sure how much you learned in geometry, but there are things called Pythagorean triples that show up over and over again. The most famous of which is 3, 4, 5. And the 5 has to be the hypotenuse. The largest side has to be the hypotenuse. Hypotenuse. I said that. And any multiple of 3, 4, 5 is also a Pythagorean triple, like 6, 8, 10. You multiplying everything by 2, or 30, 40, 50. That's why there's an infinite number of Pythagorean triples. Another famous one that shows up a lot is 5, 12, 13. I think 7, 24, 25 is another one. And you can verify by doing, is it true that 3 squared plus 4 squared equals 5 squared? I may have messed this one up. I think it's 7, 24, 25. Anyway, so now we can actually, so we already drew the reference angle, find the exact trig. Now we can find the exact of the others. Well, first of all, since they gave you sine, it might be to your benefit to do cosecant next. Just reciprocal, so you don't forget about that one. And then do cosine. Well, cosine in the fourth quadrant is positive, adjacent over hypotenuse, which means the secant will be the reciprocal of that. And then tangent in the fourth quadrant is negative, just like it says it would be. Opposite is -3, adjacent is 4, and then cotangent of alpha would be the reciprocal of that, -4/3. And it would be to your benefit to memorize these Pythagorean triples. And again, I like this reasoning, this work to explain your reasoning instead of just saying, oh, quadrant 4. Oh, I forgot to write it down. Quadrant 4 is where sine is negative and tangent is negative. So I like the picture more than I like the words. So I'll see you in the next video to finish these notes.